Hello. In this Opticam Classic video, we will be creating a simple program from a 2D drawing. So I can rotate this part around a little bit so that you can see that it's a 2D drawing. The first thing that we usually want to make sure of is that this is just lines and arcs, that we are starting from lines and arcs. You can do this by hovering your mouse cursor over the geometry and you can see that this is lines or arcs. Sometimes you bring it in depending on where you are importing this from. This might be an insert. Okay, if it's an insert, these will not be broken down to lines and arcs. That's what we call a figure, right? So it's a complete entity here that goes all the way around. All right, so in that case, you might need to go to layers and figures and explode that figure. Okay, but for this one, you can see here that these are just lines and arcs. Okay, so the very first thing that we want to do is we want to create our own figure. Okay, our profile figure for Opticam Classic. Okay, so that's the first thing that we'll do here. So as soon as I know this is where I want it, this is where I want to place my geometry, and this is lines and arcs, the first thing I'll do is create a profile figure. So I'll go up to Preparation and over to Profile Figure. Okay, so just keep in mind that everything inside of Opticam Classic kind of revolves around this profile figure. The profile figure consists of a start hole location and on profile right here, which is also known as the lead on position, and then the very third part of a profile figure is the actual lines and arcs. So this bar down here will not become active until you select a start hole and a lead on position. Okay, I'm not going to type in a new name. This is a name that you can if you want to, but I'm not going to do that for this example. Okay, this number here, this is automatically generated naming system, so you can keep it as is and just continue if you want to. Okay, so first off, we're going to go ahead and select our start hole. All right, anywhere you see these double greater than signs, this is our select button. Okay, so we'll click on this first, and then now you follow your command prompt, and your command prompt will tell you what you need to select next. Okay, so I need to select the position for my start hole. So I'm going to go ahead and select the center here at x0, y0, but I'm going to use this arc to select that. So the center of this arc. Okay, so right here I'm using the snap modes. It's on automatic right now, so depending on where my mouse cursor is, it will snap to a certain location. So right here, most of my cursor is on the inside of the arc, so it's snapping to the center of the arc. All right, so there we are. And next, I need to select my on profile or my lead-in position or lead-on position. Okay, so I'll do the same thing. I'll click on my select button, and then I'll go to here. All right, so end of this line. So right there. And then next, I do not need to select a lead off to position. This is optional. All right, most of your programs or figures, you do not need to select this. Okay, this is very specific. The third part or parameter that you need to select is your lines and arcs. So you can see this big bar down here is active. Just know that you can click on this bar also. So now I'm going to select my lines and arcs. Okay, so what I'm going to do here is I'm going to chain all of these together, so just link it together. All right, I do the chain instead of selecting on each one or windowing, just in case I have bad geometry. If I have bad geometry or gaps anywhere in my geometry, the chain or link will stop. Okay, at that position, so that I can go fix that before I actually create my figure. Okay, so I'm going to go ahead and click on this, and then click on one of these segments, and then it will link all together. Once I'm done, I need to remember to click on In Command. All right. Okay. So here's the report that popped up. All right. Close figure 000 is successfully created, and it gives me some more information down here about the figure that was created. Okay. All right. So now this window will always pop up just in case you have multiple shapes you need to create or multiple figures to create. On this one, this is the only one I have, so I'll click OK or Done. All right. So next, now when I hover my mouse cursor over the geometry, you can see that it is now no longer just lines and arcs. It is an insert now. All right. So it is a profile figure now. So when I click on it to highlight it, it selects the whole thing. It also shows me where my lead on position is, as well as my start hole. So right hand now it's hidden behind the origin, but that's fine. Okay. So the next step, now that we've created our profile figure, is to create our machining. So I'll go to machining. And we have 3 different type of machinings functions that we can use: a standard profile, the collar, or the ruled surface. Standard profile we use probably the most often. The collar is just 2 standard profiles in one machining operation, and then ruled surface is our 4-axis machining. Okay, for this example, we will be using standard profile. Okay, so I'm clicking on standard profile. Need to specify what units I'm working in. Then now this dialog page comes up. This dialog page right here is our operation sequence. Okay, so our workpiece. So first thing I need to do here, you do not need to fill all of these out to create a program, but for this example I will. Okay, so the billet is the first page on here. The billet is just a representation of the block that you will be cutting this part out of. Okay, so because we do not have a block already created, we cannot use the select button. So what I'm going to use instead is just new. I'm going to click on new. And in here you have different types of billet shapes that you can create. All right. So for circular, rectangular, from lines and arcs, from a figure even, okay, or creating a solid. All right, for this one, I'm going to be using rectangular, and I'll just choose the XY minimum and XY maximum corners, and then to specify the size of my block that I'm going to cut this shape out of. So once again, clicking on this select button. All right, XY minimum down here, and then selecting my XY maximum up here. Okay, and then I need to tell it how thick my material is. So for this part, I'll go ahead and put in 1 inch. Okay, if you know that your block is going to be sitting on some sort of a fixture, you can add that height to the B height. And once you're done there, you can click OK. You can see out here, I created my billet. Next page is output file. All right, this is where you give your NC file name. You type that in here. This is where you also select where your NC file will be posted to. Okay, so right now it's set to our default folder, which is the user public documents Opticam Classic version 2022 NC Wire Makino folder. Okay, so it's going to post there, but keep in mind that you can also copy it to a different location after posting. Okay, next is our from position and our reference position right here. So from position where our nozzles drop in, reference position is our origin. Okay, for the Makino, let me go ahead and change this to G54. Okay, and then you can see here our secondary plane and reference plane. So these planes right here carried over from when I created my billet. Okay, and these nozzles heights here are just for simulation purposes inside of the software. Okay, so next page, technology here, selecting the material that I'm cutting as well as my wire size. Okay, wire type as well. All right, so For the most part, you are done with the workpiece. All right. You also have strategy here, but usually we use our Opticam Classic sequence strategy, and then you have some options here for adding another more description. But usually, first 3 pages here are the main 3 pages you want to make sure that you look through to make sure all of your materials are set properly. Okay, materials and heights. Okay, all right. So once we're done with that, the standard profile page will pop up. Okay, all right. First thing that I want to do here, right, is select my figure or figures. Okay, if you have multiple figures, just know that the order that you select your figures in is the order that they will cut in. Okay, I only have one here, so I'll go ahead and click on my select button and then click on my figure and make sure that I click in command. All right. Next, I'll select my technology. For each machine or post, you might have a slightly different way of selecting technology. Okay, so for the Makino, you can select it directly inside of software here. I'm going to go ahead and select technology. All right, make sure I agree to the terms of license, and then now I can select my technology. So I'm going to go with both away precision, and then I'll use 50, finish 50, which has 3 passes. And that's the only thing I need to select here. Okay, so I'll tell it to load technology. And then now, if I go to my setup button down here, you can see my technology has been loaded with my different offsets. Okay, if you need to get more specific into what these numbers are, you can click on the set tech, these 3 dots here, and you can tell what the power values are also. Okay. All right. You can also add a comment for each one of these passes if you need it. Okay. So cutting setup, this page right here, this is also where you can have reverse cutting. So it will alternate the direction of the cut every other cut. Okay. We have our offset geometry right here. These are different options that you can turn on or off depending on what you need for your specific program. Sometimes you might have some undercutting with the offsets. Maybe you need to apply the offset numbers directly to the code, right? So that's what offset geometry is for. Or maybe some of those corners might be smaller than your offsets, and you might run into some issues there. You can turn on modify internal corners to fix that. We also have additional clearance on here. If you need to leave more material on or cut more material off, you can add a positive or negative number in here, which will add on to your offset to allow for more material left on or more material cut off. Next page is tagging. This is the size of our glue stop, our bridge, or in Opticam Classic, we call it a tag. Okay, I'm going to use 50 here. My lead off value is how far my program leads off at the end of the cut. Right? So sometimes your start hole is really far away. If you set a smaller lead off, it will not go all the way back to your start hole. It will just lead off that certain distance before coming back on and continuing with the second and third pass. So that might save you a little bit of time. Okay? All right. And then down here, we have our different tag removal methods. When do you want to cut the tag off and drop your slug? Okay? So different methods down here for that. So for this example, we'll be using the very first tag removal method. We're going to go ahead and stop and then cut the wire, cut the tags on the first cut. Okay. All right. And then we have our lead options here, how you want to lead on, how you want to lead off, as well as our offset button here. Okay, our offset button here is for direction of your cut, as well as what side you are cutting on. Because we have a closed profile, we can leave it on auto direction and it will cut on the same side as your start hole. Okay. All right, I'll go ahead and click OK here and then OK again. And then we're basically done creating a program using our 2D geometry here. Okay, so you can see here my billet is the block on the outside, and then my cut or my geometry is on the inside here. Okay, so after you've created a program, you will usually see these pink and green lines. This is what we call the wireframe NC. Okay, couple of ways of turning that on and off depending on what you're comfortable with. So one way is to go into your workspace over here and just uncheck it. All right. The other way is to go to your simulation menu and then tell it to remove your wireframe NC or recreate your wireframe NC. Okay. All right. You also notice here is the lead off distance that was set earlier. Okay. All right. So from here you can run your simulation and then post your code. You don't have to run the simulation, but it's nice to see what's going on here before you post your code and send it to the machine. All right. So under your simulation menu, you have a couple of different options here. Okay. So we have our wireframe simulation all the way on the end, and then we also have our standard simulation here, which is our solid simulation. Okay. All right. So on here, I'm going to use my solid simulation. There's also an option for a new and old simulation. This might not be active on everybody's license. Okay, so I'll go ahead and press play here, and we'll take a look at the simulation. All right, this is our old style simulation, okay, that we've had in previous versions. All right, so let me go ahead and just make a few changes to some of the options here of what I'm used to seeing. Okay, first off, over here on my right, I have different views that I can switch to, and then I have different options to display certain items. My wire, my nozzles, the billet. All right, so on here, let me make the billet a little bit more transparent just so that we can see through it. All right, so that we can see what's going on. All right. Yeah, so that's good. So next, down here at the bottom, I want to make sure that I turn on my optional stops, which is already on, which is good. That will stop where I set my tag. And let me also slow this down just a little bit so that we can see what's going on. Okay, so now I'm going to go ahead and press play. And we'll take a look at what we programmed. Okay, so where there's the wire. Each pass has its own color in the simulation. So first pass is red. Okay, so right here is our optional stop. Let me rotate this around so that we can see the sides of that. There is my optional stop. Okay, so when I press play again, that will cut our tag and drop our slug. All right. There it is. There's my slug. So I can also see how, or test how, it can be removed. So I can tell it to separate here. And I can see that my slug can be dropped in the Z positive or Z negative direction. Okay. All right. So I'm just going to tell it to remove the highlighted solid and continue. Second pass is in green, and remember that I turned on reverse cutting, so that's why this is cutting in the opposite direction. All right, third pass is in yellow. All right, and that's done. Okay, so that's our simulation. So when I click done, it'll go back to my machine. Okay, machining. So here I can rotate this around and kind of see my different passes here as well. Okay, all right, and make sure that nothing weird is going on in those corners. All right. So once I'm satisfied with everything there, if I saw anything, I can always go back to my standard profile and make some adjustments. All right. So if you double click over here in your workspace on the machining profile that you created, you can go back and make some changes. If you need to change your technology, if you need to change your tag size, you can do all of that here. Okay. All right. So you don't have to recreate the whole thing. You can always just go back and make those changes. All right. So now we can post our code. There are several locations that you can click on to post the code. So I have some shortcut icons up here that I can use. Right. So this right here, this little sheet of paper with some code on it and an arrow going down is one way that I can do it. I can click on that. I can go to my file menu and post process from there, and then I can also use my utilities menu over here and also post process. So multiple different locations where you can post the program from. I'm just used to this shortcut right up here. I'm just going to click on that and post my code. All right, so you can see here for the Makino there is only one ISO file output. Okay, so here you have different options also. Okay, so first option here is to copy this file to a certain location. So if you go to options, you can see that this is the location where I can copy that file to. So you can browse to whichever folder, whichever location you need to copy the NC file to. I'm going to go ahead and click done there. The second option on here is to show the NC file, kind of preview the code. So I can click on this to take a look at the code that was output. Okay, it just opens Notepad. That's all it is. So we have our 3 passes up here. Our first pass here, calling up our power values and our first offset. All right, and then it continues through. All right. Okay. And I can close that and click done. And that is just a very, very simple example of creating a program from our 2D drawing. Thank you.